Welcome to our first video about networking. In this video, we will talk briefly about how do computers communicate together over a network. A network is a collection of computers and other devices that are connected together so that they can communicate with each other for the purpose of sharing information and resources. There are several devices that allow computers across the internet to communicate together. Let me first introduce two important devices on a network. These would be the switch and the router. The difference between the switch and a router is very simple. A switch knows how to connect multiple computers together that are on the same network. A router knows how to send packets out of an internal network out to the internet. Nowadays, in our home networks, we have one device that acts as a router and a switch at the same time. Let's imagine now what is happening when this computer here, number one, needs to communicate with this computer here, which is number two. Computer number one will send its packet through the switch to the router and say that this message is meant to go to computer number two. But computer number one itself doesn't know how to send it there, so it sends it to the router. The router is the one that knows where to send it from this point to the next router in the internet. And the internet, you can think of it as a network of routers that can route this packet or message until they can reach this router over here. Once this message is received by this router here knows where to send it exactly such that it arrives at computer number two. When computer number two wants to respond back to that message, they send their packet to this router over here, which then sends it out to the next router in the internet, and the collection of routers on the internet keep sending this packet to each other until they can reach this router over here, which knows how to send that packet back to computer number one. But in order to do that, each of these communicating computers over that network must have something called a network address. Think of a network address like your cell phone number. Network addresses are assigned to computers on the internet in the form of a 32-bit binary numbers. This means that we have a total of 4 billion possible addresses. An example of a network address is shown to you over here in its plain 32-bit binary representation. But that certainly is not a human readable way that will allow us to communicate these addresses in an efficient way. This is why we have to find an easier way to work with these addresses by converting each group of 8 bits in these addresses into their decimal equivalent through a process called the 4-octet dotted decimal, which then gives us something that we will call the IP address of a machine. So if we have this number here, then we divide it into 4 octets, 1, 2, 3, 4, and we put dots between these octets. So this is a dot, and a dot. And then we convert these octets into their decimal equivalent. So the first octet here is going to be converted from binary to decimal. So this is 1, 2, 4, 8, 16, 32, 64, and 128. So this number is equivalent to 128 plus 64 plus 8, which is 200. And then we'll convert the next one. So this is 2, 4, 8, 16, 32, 64, and when you add all these up, the answer is 114. In the following octet, this is 2 and 4, so it's going to be 6. And in the following octet, this is 1, 2, 4, 8, 16, 32. And when we add these up, the result is 51. So the representation of this 4-octet dotted in a decimal way would be 200.114.6.51. And this one here is the number that we will call the IP address of a machine. So the 32-bit address used on the internet are referred to as the IP address, as we said. And whenever you see an address that looks like that, you know that it is a representation of a very long 32-bit address, where this first number here is translated back to this binary, and then this number is translated to this binary, this number is translated to this binary, and this number is translated to this binary. And now you have an understanding of what is an IP address and how we represent it in the 4-octet dotted decimal representation. So let's take a look again at this scenario. That's the tail of a packet. Let's imagine that this computer here has the IP address 192.168.7.12, and it needs to connect to YouTube, which has the address of 172.217.12.238. How does that happen? First of all, this machine sends its packet to the switch, and then the switch sends it to the router. And the router doesn't know where 172.217.12 is, so the router sends it to the next router in the internet, the next router sends it to the next router sends it to the next router, until it receives the router that knows where 172.217.12.238 is, and then it forwards it to YouTube servers, and then YouTube servers process this packet and probably sends you back something that goes back the same way until it reaches that router, and then that router here knows how to address this packet back to your own machine. One important concept I want you to be familiar with at this point is that due to having a large number of machines that need to communicate to the internet nowadays, the 4 billion addresses that we talked about earlier are not enough to be assigned to every machine available on Earth nowadays. So we need a way around the necessity to assign one of these 4 billion IP addresses to each machine that needs to connect to a network. To do that, we are using something that's called Network Address Translation, and the short for it is NAT. And this means that each of these networks behind a router can have its own private IP addresses that belongs to itself that no one knows other than the router that is dedicated to this network. So let me show you an example. Let's call this network 1, and let's call this one here network 2. So in network 1, we have a machine that has the IP address of 192.168.7.12, and we can also have 192.168.7.12 in this network as well. However, the IP address of this router is different than the IP address of this router. So let's think that the IP address of this router is 69.7. whatever, and the IP address of this router here is 52.17. whatever. So now, how does this computer connect to this computer? A packet that is being sent by this computer here goes to its own router, which then finds a way to send it to this router such that on the internet, it appears that 69.7. something is connecting with 52.17. something. And the internal machines are hidden behind these routers. And only these routers are the ones that are able to communicate with their internal computers. So when this computer over here wants to send something here, this router sends it to this router, and then this router sends it internally to the computer on that network that has 192.16.168.7.12. In the next video, we will see how can we create such networks that will say what's the name of my network and who are the computers in that network that I can communicate with. And for every network, we will have a gateway IP address. This gateway is the one that's responsible for our communication with other machines that are outside of our network.